Hey guys, so today we're going to talk about probability. So, the thing about probability is that it's like the chances that something will happen. So, what we've been doing is finding out the total number of possible outcomes. So, just as a review, here we have a class of 27 must choose students to represent them in a trivia game. That's choosing out of a group. So, since they're all just playing a trivia game, they're all doing the same thing. So that's a C. The first number is 27. The second number is 3. So that is 2,925. Then there's a company must hire an assistant, an accountant, and a vice president from 16 applicants. Since those are different jobs, that's a P. Which would be 3,360. So anyway, the sample space as a review is like a list of all the possible outcomes. So suppose you roll a die and flip a coin. What is the sample space? Well, you could get a 1 with heads or tails, a 2 with heads or tails, and all the way down to 6. So there's 12 different things that could happen. You could do this with a table. This is a tree diagram, but that's all the different possible things that could happen. Okay, so the reason why that's important is because when we're dealing with, technically it's theoretical probability. First off, whatever the event is, like if the event, we'll just say it's A, the way that you denote probabilities, you put a P, and then you put the event in parentheses like that. So that's the probability of A happening, whatever A is. Well, to find it, you would say the number of times, the number of ways A could occur, over the total possible outcomes. That's why the total possible outcomes is important. So it's always just the number of ways that A could occur over the total possible outcomes. So for probability, it's always between, the probability of any event is always between 0 and 1. 1 would be like a 100% chance, definitely going to happen. It's the only possible thing that could happen. 0 is like 0% chance. It literally is impossible, and everything else is in between. So if you end up with an answer that's bigger than 1 or negative, then it's not right. So just keep that in mind. So example would be like, okay, so we've got a jar. There's 3 red balls, 5 yellow balls, and 7 purple balls. So to find the probability of red, well, there's 3 red balls. So that's the event. There's 3 possible times that the event could occur. Total, there's 15. Right? So the probability of red is 3 over 15, which is 0.2 or 20%. Generally, probabilities are expressed with a decimal. So you can just leave it as a decimal. If you wanted to turn it into a percent, you would just multiply it by 100 or move the decimal place over twice. But there's a 20% chance that it could be red. So if you have the probability of purple or yellow, right, there's 5 yellow balls and 7 purple balls. So that would be 12 over 15, which is, well, it's just 0.8. So there's an 80% chance. And if you'll notice, if you add those two things together, it'd be 1, because red, purple, or yellow, I mean, that is, the things. Okay. So suppose you roll a 6-sided die. We'll find the probability of each event. Well, there's 6 possible things that could happen if you roll a die. There's 1, 2, 3, 4, 5, and 6. So the probability of getting a 2 is just going to be 1 out over 6, which is 0.16 repeating. The probability of getting an even number, well, their even numbers are 2, 4, and 6, so that's 3 out of 6, which is just 0.5. The probability of getting less than 5, well, that'd be 1, 2, 3, or 4. So there's 4 ways that could happen, which is 0.67. And the probability of getting a 1 or a 6 is going to be 2 out of 6, which is 0.33. So pretty straightforward with that. I'm not going to do that. So this is where it gets a little bit tricky, though. So there's some problems like this on the work today where, okay, there are 12 shirts in your closet, 6 blue and 6 green. 2 of the blue shirts and 4 of the green shirts fit well. The rest are too big. You randomly select a shirt to wear. Find the probability that it's blue or too big. So with these, where there's 2 different things they're talking about, the color of the shirt and whether or not it fits, those definitely you want to draw out the sample space. So there's 12 shirts total, 6 blue and 6 green. So I'm going to put 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. 6 blue and 6 green. 2 of the blue shirts fit well. So I'm going to put like a little F for fits. 4 of the green shirts fit well, so fits. So so that means total there's 12. To find the probability that it is blue or too big, I'm going to circle all of the ones that are blue. So every blue shirt, and then if there are any green ones that are too big. So that's 8 out of 12, which is 0.6 repeating. Okay. So there you go. Okay. So here, this is the actual work for today. So I'm just going to go over a couple of them. So a bag contains 4 yellow jerseys numbered 1 to 4. So I've got yellow 1, yellow 2, yellow 3, yellow 4. The bag also contains 3 purple jerseys labeled 1 to 3. So purple 1, purple 2, purple 3. You randomly pick a jersey that is purple. So find the probability that it is purple or greater than 2. So I'm finding the probability of purple or greater than 2. So that means I'm going to circle all the purple shirts and then any other shirts that are also bigger than 2. So that would be sorry, 5 out of 7, which is 0.71. A litter of kittens consists of 2 gray kittens, 2 black kittens, and 3 mixed colored kittens. So I've got 2 gray, 2 black, and 3 mixed. So you randomly pick a kitten. What's the probability that it is gray or mixed? So these, I'm just going to circle all the gray ones and all the mixed ones, which is again 5 out of 7, or 0.71. So, and just so you know, I found the decimal by just doing 5 divided by 7. So I'm just going to leave it there. I'll go over more of these tomorrow. But anyway, we're going to spend a couple days on just basic probability. So anyway, if you have questions, let me know. And yeah, that's it.